appreciate you sticking around seeing me tonight. I know it's not easy to give up your evenings sometimes. So my talk is called OK Computer. This is actually the second version of this talk. I sent them the first one, but they told me it was too small and sent it back to me. But ASOS joke. Come on. All right, no jokes. Memo to yourself, no jokes. My name is Peter Gasston. I'm creative technologist at Rehab Studio, just down the road in London's trendy Silicon Valley, Silicon Roundabout, I should say. If you want to critique my jokes, stops at green. If you want to read what I write, then brokenlinks.com. This is ASCII Red. This is Intel's last supercomputer. It cost them £43 million to develop in today's money, significantly more back then, and it could process at its peak in 2000 1.8 teraflops, which is 1.8 followed by 11 zeros. This is the PlayStation 3. This came out in 2005. It cost £425 and it could process 1.8 teraflops, the same as the ASCII Red. This is a picture of a cat. It's only notable as a picture of a cat because it's the first cat that Google trained its computers to recognize itself. Nobody told the computer this was a cat, it learned it itself using some very sophisticated deep learning techniques and 16,000 connected processors. That was in 2012. In 2015, the same technology can now recognize that this is a picture of a man using his laptop while his cat looks at the screen in 3 years. And this is Watson, which was built by IBM. They built it largely for one stated aim, which was to beat the human champion at the game show Jeopardy! It took them about 10 years of development. It's hard to get costs, but it cost roughly around £12 million in total to develop it. And this is a picture of it beating the human champion at Jeopardy! It beat its nearest rival by over 3 times the amount of points. The one, in case you're wondering, the one in the middle is Watson. And this is the Cognitoids Dino. It costs £80 and it's powered by Watson. The point is this: artificial intelligence is becoming very good very quickly. We're talking about the timescale of 3 to 5 years for a lot of these things. There's a lot of different strands to AI, but the big breakthroughs in the last few years have been a process called deep learning. Deep learning works in a way where you provide it with an input, then a series of classifications are run over it, and then it gives you an output. But it's not just as simple as my diagram here. It will get passed up through various different nodes. Each node has one dedicated job. You can see here that it's looking for a diagonal line in one of them. Later that gets passed, the result of that gets passed up the strand until it finds a face. The result gets passed up until it realizes it's the face of a cat. That can go on for up to 25 layers in some of the smartest systems today. It works kind of like your brain. This is often called a neural network. It works in a very similar way that we work. It will give you a very rough, fast answer and then a slower, more considered, precise answer, just the same as we do. What this means is, for example, you can take an input or 2 inputs like this. The input you can see on my pointer's not very good because of the screen. You can see the input on the left-hand side at the top is a picture by Van Gogh, and below that is a photograph of some houses. And then each of those is run through the deep learning system. The system at the top learns how the image is painted, and the system at the bottom learns the content of the photograph. And at the end, it can output that photograph as if it were painted by some of the old masters. You'll notice it's not just applying a filter to the thing. It understands what is sky, what is buildings, what is water, and styles them all differently and totally appropriately in the style of Turner, Van Gogh, and Munch. And having conquered the world of art, now artificial intelligence is coming for your job. This was a recent article produced by Gartner where they assessed the risk of your job being replaced by machines. Basically, it works in there's routine to variety along the one-axis, and there's numbers to abstractions along the vertical axis. If your job involves a lot of variety and a lot of abstractions, you're probably all right. If your job is somewhere between routine and involves a lot of pictures or words or people, you should probably start getting nervous. And if your job involves numbers or words and is very routine, it's pretty much bye-bye. One recent study showed that in major US corporations, the finance department have lost 40% of their staff in the last 10 years have been replaced by automation. You as a developer or a designer or whatever it is you do as a web professional, you probably think, well, that doesn't really apply to me. This is from the BBC. The BBC says a web professional says it's not very likely that your job will become automated. It's not very likely, they say 21%. 21%, put another way, means that 1 in 5 of us could see our roles automated over the next 4 or 5 years. If your job is quite routine, you do the same thing all the time, you're probably down there in that bye-bye category. And we're starting to see this move into, I'm not saying we'll all be laid off, we're going to be replaced, but the job pool will start to shrink. There will be fewer jobs available to us. We can see this starting to happen already, of this automation moving into the industry, with services like Download Me, which just you give it your social feeds and your brand information, and it creates a native mobile app for you in about 10 minutes. There's the same, this App Machine does the same. You just tell it information about yourself, it creates a mobile web app for you, fully automated. You might think it's kind of difficult and complicated. It's not. You can just put your Facebook name in to start, and it will create a web app for you based around your Facebook details if you're a business in a matter of minutes. This is more than Squarespace. Squarespace is just a templating system. It relies on you to do a lot of work. This relies on you knowing nothing and doing no work, and it will build something for you. And you might have seen this advertised a lot recently. This is the grid. If you use Facebook or Twitter, and you've probably been targeted with ads for this thing. This is a similar thing. It will build a whole website for you. You tell it a bit about yourself. It builds a full web presence designed for your business. Now you're probably thinking, all right, but that's going to be that can't be that creative, it can't be that interesting, all of these websites are going to look the same, it's going to be boring. All of these websites here were designed by people. All of these websites here look the same and boring. We're part of the problem. The problem is the work we produce is repeatable and predictable. I'm generalizing here. I don't want to say this about all of you, but generally the work we produce, websites like that, are becoming very homogeneous. We build buckets and templates to hold the content. Digital design has become a human assembly line. A human assembly line kind of sounds like we're down in the routine area, down the bottom. Routine, words, pictures, and numbers. If you're thinking, well, I'm a programmer, my job's safe, that can only replace the design side of it, the front end. There was recently, this is a new breakthrough by a university, they've created an algorithm that can take code from one code base and transplant it into another one without any human intervention, without being trained on either one. Recently, it took the H.264 codec from X.264 and put it into VLC, the app. It took 26 hours for the computer to do that. Meanwhile, the VLC team were doing it at the same time. It took them 20 days to achieve the same thing. And Helium is a system that you can give it code, it will learn what the code does and improve it in a matter of hours or even minutes. As an example, they ran it on some Photoshop plugins. This computer, this system had never seen these plugins before. It didn't know what they were. It learned all of what they did, and it improved them by between 75 and 500% performance. AI can't do our jobs, but it can do bits of our jobs. And the bits that it can do is going to become more and more frequent in the future. If that prediction in the BBC is correct, it will be doing the jobs of 20% of us in the next 4 to 5 years. And we've kind of done this to ourselves, as I said before. We've got this kind of automation line going on, but it's also in programming. We're building the systems and the things to make our jobs efficient. All the frameworks and the tools we use make us more efficient. they also make us more prone to automation. We're designing ourselves into this environment. I'm not arguing against these tools. These tools are really, really useful, but this is happening because the things that benefit us will benefit automation. This quote, and a quote I used previously, are from a fantastic article called Design Machines by a guy called Travis Gertz. I really, really, really recommend you read it. I've got a link in my slides, which I'll put up later. But it's not an article just complaining, it's not just saying what the problem is, but it proposes a solution. The solution is that human beings are unpredictable, mushy bags of irrationality and emotion. This is a good thing. Creativity is a tool that we can use that computers can't. I don't know if you've heard of DeepMind. Anybody heard of, sorry, Deep Dream? Have you heard of Deep Dream, anyone? This is this algorithm. This is Google's neural network visualized. It kind of, you put images in, it shows what it's thinking, it's working out, and it kind of comes up with these crazy things. And as Brendan Dawes said, Deep Dream is clever, but it's proof that computers lack what humans have, which is good taste. You can't train an algorithm to have good taste and creativity. I'm sure many of you have heard of the Turing test. The Turing test is a way for, it tests if a computer can realize that it's, if a human can realize that it's talking to a computer. But that's not really the benchmark, because we can fake that. We can work things away to get around that. The real benchmark should be, there's a test called the Lovelace Test, which is a little less well known. The Lovelace Test is a benchmark of creativity. It says human intelligence has creativity. So if a computer thinks like a human, it must be creative. In order to achieve that, it must produce an original program, which can be a piece of music or a poem, that it was not engineered to produce. So it must produce something original that the programmers never told it to do. And it must be able to do that reproducibly. It must be able to reproduce that and do it again. And it must be unexplainable by the original programmers. So the computer must be able to come up with a creative test for itself. It is, hopefully, an impossible test. A computer should never, ever be able to do that. If it does, then we're in real trouble. So we need to enable people to do non-routine, non-repetitive tasks. This isn't some run-of-the-mill web designer saying this. This is a guy called Andrew Ng, who created or drove a lot of Google's artificial intelligence program. He's now working for Baidu in China, one of the major players, and he's very, very worried about the effect that this is going to have on the job market. He thinks that we have to teach people to be innovative and creative in the future. Cameron Moll, who is your very good web designer, makes the point that mastery of creation and composition is more important than mastery of tools. But AI is a tool that we can use as well. We don't have to sit passively back and watch it just kind of move into our market. We can use it. And AI, I mentioned earlier about the grid. Now, the grid, I would say, uses automation techniques, but it's not truly artificially intelligent. It's doing smart stuff, very smart stuff, but it's not really using intelligence so much. A lot of their selling points, for example, they use smart image cropping, where they detect the content of an image and to work out where the faces are and crop images so they're a bit more smart when you resize the screens and on different devices. We can do that with Python libraries like Thumbor. We've been able to do that for a little while now. And they find a color palette based on your brand and your images. We can do that quite easily. This is a JavaScript library called Color Thief, which analyzes your photos and gets the dominant color and returns you a sympathetic palette. And it's all based on this thing called grid style sheets, which is a JavaScript and CSS re-implementation of the native layouts in iOS. They're kind of content aware and they resize them and make themselves perfectly spaced based on the content that they contain. So they're smart. But I think we can use AI to provide better services to our users. And I think we're going to have to, because I think AI is going to become a cornerstone of user experience. I agree with this. We're going to see this happen. We're going to have to learn to adapt. People are going to start having expectations set. I think, in addition to all of the things that we currently have to do, that's visual design, motion design, interaction design, everything we have to do now, we're going to have to add another string, which is intelligence design. But the good thing is, I said earlier that artificial intelligence is becoming very good very quickly. The very, very good thing is that it's becoming very available very quickly. Things that were the domain of a few huge internet giants 2 years ago are now accessible through JSON APIs, REST APIs, for next to nothing or nothing. I spoke about Watson at the beginning, the Watson supercomputer. They have this fantastic program called Build with Watson, which makes all the learning powers of Watson, 10 years of development, £12 million, available through a bunch of RESTful APIs. You have to work on their cloud platform, which is called Bluemix. It's very similar to Amazon Web Services or Google Cloud Platform or Microsoft Azure. But they've released these whole bunch of APIs recently, and they actively want people to be working on them. They will reward you if you use their services. They will make you an official partner. They want to be the platform of artificial intelligence, as the PC was, as Windows was to the desktop PC, and as kind of arguably Android is to mobile. It's kind of the open platform that anybody can use. That's what they want Watson to be. As an example of some of the services that Watson provides, they have smart image processing. They can work out, like that service I showed you at the beginning, they can work out the content of an image without ever seeing it before. Here you can see, given a picture of a tiger, it's identified with 78% certainty that that's a picture of a tiger, that it's 75% certain it's a wild cat. It goes down, so it's got 50% certainty it's food, which I guess is kind of true, like at the end of its life cycle when the flies and maggots move in. And given a picture of me, it's recognised that I'm a person with 71% certainty, which is a lot better than some of the people I know. It has picked up on this kind of weird thing that apparently it's wrestling combat sport. It thinks that I'm a wrestler, and I was a bit stumped by that until I realised it must have been looking at my old Flickr pictures. But when it misidentifies stuff, the good thing is that deep learning systems get better with training. The more data you give them, and the more you tell them this is right and this is wrong, they learn. They're learning systems. That's the whole point of them. Which is why every photo service nowadays offers something like this, and they're all free. Google Photos, Flickr, IM, there's a ton more. They're all free. They give you unlimited storage practically to all intents and purposes. And the reason is your data makes their service better. Your photographs make their service better. And the more you tag or remove tags from your photographs, their service gets better. If you've used Google Photos, you'll know that it's kind of quite miraculous. If you haven't, you should show it to someone. You should get someone to show it to you. You can just search your photos, and it returns the photos from the search term you've given it, even though it should, by all rights, have no idea what's in those photos. I searched for birds, and it returned all the photographs that I'd taken of birds. I'd never tagged those with birds. I'd never put them in a post saying they were birds. It just learned that that's what a bird looks like. So it knows when I search, those are the birds in my photos. And it does it instantaneously. And these types of things are going to become so prevalent that what I was talking about before, at a certain point your users' expectations are going to be raised by this thing. If you're running a service which hosts photos and you don't provide this kind of smart search, your users are going to start thinking your service is kind of a little bit inferior, probably. Watson, again, provides really nice tools for doing this. You can give it your entire photo library, and it will tell you what your interests are based on all of your photos. For example, it can tell you that there's a high probability that I like animals. Sorry, this isn't mine, but imagine these words. High probability I like animals and fashion, and that I like the outdoors, and I like cycling. And it's learned this from all my photos. So what it can do is target me better. This is what advertisers have been doing to you for years. All of the data, everything you put in there, they know what you like, and so they target ads back at you. But now this stuff, which used to be expensive, has become very, very cheap and ubiquitous. So you can start targeting your users in return. It can learn your personality, whether you're artistic, you're intellectual, not just from your photographs, but from all the content you put into it as well. You can do this now with Watson APIs. Watson's not the only game in town. I'm not here paid for by Watson or working for Watson. They're just very, very good. Microsoft have their own version called Project Oxford, which has a bunch of REST APIs and SDKs. It's what powers Cortana and Microsoft services. Most of this is now becoming available to you as a developer. It only works on .NET or Android for now, but expect that to go to more platforms in the future. What Project Oxford excel at is their image recognition is pretty good. It's not as good as Watson's, but you can see here that it's identified that this is a building and it's black and white, and it can tell me some things about it. Is it difficult? Yeah. What I really like about this though is it tells me if there's racy content in your photographs. Is it a racy photograph? Which gave me a nice idea for an app where I just keep the webcam on me and keep making poses until it identifies me as racy. And then I go out and I repeat that pose. But what it's really, really good at is face detection. This excels over Watson at face detection. There's a whole bunch of services that can do. It can detect faces, it can recognize faces, it can verify faces based on existing photos. It can work out your age, it can find faces very similar to yours. I don't know if you saw recently there was a site that went around where you uploaded a photo of yourself and it told you your age. That was powered by this, and if you did it for a bit of a laugh, you were helping their system get better as well. I really like it because I uploaded this photograph and it was told me I was 5 years younger than I actually am. But it's not just the big boys playing at this. This is what I said, it's way, way more available now. This is a startup called MetaMind, which is a consumer-focused startup which offers some of the same tools of image recognition and text analysis. And there's one called SkyMind, which does a similar thing for enterprise clients. And again, their kind of detection is pretty good. This is a photograph of me. It's recognized that there's a mountain bike, there's a suspension bridge. Its degrees of certainty are not as high, but you know, the more you use it, the better it gets. Detecting photographs and that kind of stuff is very cool. But the killer app of AI is natural language understanding, natural language processing. For the first time in the recent years, you can start talking to your computer as if it were just another person. You don't have to type like a Google query where you target the words specifically to find a result. You just speak to it. If you haven't used Google recently, this is really cool. You can just say to it things like, how long does it take to get from here to the capital of France? It knows the capital of France is Paris. It knows that I want to get directions, and it returns reports back to me. But I don't have to structure that in the old googly way. I just speak to it as if I were asking you. Not that I expect you to know how long it gets to France. And the latest version of OS X, El Capitan, now has this natural language input for files, where instead of, if you know that you're searching for a document that you worked on last week, instead of opening up a text field and doing drop downs, you just say to it, show me the documents I worked on last week. Again, Watson does this stuff. It has a really nice question and answer API where you can ask it a question in natural language and it will return you just the answer. Not a page with the answer on it, but the correct answer from the data in its pages. And a natural language classifier which just lets it know what the thing you told it is about. And that's more smart than it seems, because for example, if I ask it, is it going to be sunny tomorrow? It knows I'm asking about the weather. But if I ask it, will it be warm tomorrow? It knows I'm asking about the temperature. So it knows the difference of this stuff. That's the key thing in natural language. And there's the Alchemy API. Some of you may have used this. It's been around for a little while. It's actually been bought by IBM now, who own Watson, so it's going to become part of Watson. But there's 12 text analysis APIs which use natural language processing. So you give it documents and it just understands their contents. If you've used any services like Pocket or Shutterstock, you know when you search for something, it gives you back results based on not only what you've searched for, but things that might be related, or they give you recommendations to read based on the things you've read. They all use services like this. Amazon, Netflix, Google News, pretty much anything nowadays which has a recommendation system uses natural language processing to understand the things, not just look at related words in the title. It's not looking at keywords, it's looking for subjects and themes. Netflix say 2/3 of their views are from recommendations. But what AI excels at really is conversation. And this is not just chatbots. Chatbots have been around for ages. This is Anna, who is IKEA's support chatbot. And she's been on their website since about 2008. But Anna is kind of, if you'll pardon me saying so, Anna, kind of stupid. You ask her a question, she'll reply to you. If you then ask her the same question in a different way, she might not understand it and give you an entirely different answer. Or if you ask her a question and then ask her a related question, she won't understand that the two things are connected. But things are much better now. This is still a prototype, it's not available yet, but Google have been training their own system like this. What they did is they took loads and loads of support calls and IT support correspondence, and they fed it all into their computers, and they've created a system which can now provide IT support without the other person knowing most of the time that they're speaking to a machine. It just keeps going until it gets all the answers it requires. It might not seem perfectly human, but for most people, they don't care. This is the critical thing about the new wave of chatbots, is that dialogue systems have to maintain context. And this is what they can do. That Google chatbot can remember the previous question and refer back to it, or can understand your follow-up question. Again, if you've used Google recently, this is really cool. You can ask it, who is the star of, I don't know, I get blank now, but say the answer was Susan Sarandon, then you could say, and who is she married to? And it would say, Tim Robbins. And then you say, what films did he star in? And it would show you. It's just followed that context through your conversation. Something that wouldn't have been possible a few years ago, except for big systems. And what this has enabled is where we are now, which is the way of virtual assistants. Every phone, every operating system now has a virtual assistant attached to it. We've got Siri, we've got the Google Voice Search, we've got Cortana, we've got Amazon Echo, which is kind of an interesting use case because Echo has now come off of your phone and moved into your house. It's doing the same. If you haven't seen this before, it's a little cylinder that sits in your house and you can just ask it questions or tell it to do things or give it commands, tell it to play music, ask it to, hopefully, because it's from Amazon, buy something for you. And we're starting to see this become huge. We're starting to see this kind of thing move into the home. This is a system called Jibo, which is built by a lady named Cynthia Brazil, who's like one of the leading robot emotional leading people in robot emotions, and she's moved into the home assistant market as well with this Jibo. And it's beautifully designed. It kind of looks like something from WALL-E, something from Apple, and it moves really fluidly and beautifully. And then you have its kind of poor relation cousin, Mycroft, who kind of sits next to it with a snaggletooth grin and kind of looks a bit like next to its siblings, just looks a bit sorry for itself. I love this because it kind of reminds me of if you ask your parents to go out and buy your Justice League toy set and they come back with the Sense of Right Alliance featuring Superman, Batman, and Shrek. You know, it's just the intention's there, but the budget has not stretched. That's basically the same thing. But Mycroft does what Jibo does. It sits in your home and it answers all your correspondence and you can talk to it. It's all based on open source software. Jibo is proprietary, but Mycroft is all open source. It's just been Kickstarter funded. And we're going to see loads and loads more of these things in the future. This is because, and to communicate with these things, the big advantage is there's no keyboard, there's no app input. You just talk to them as if they were your friends. Conversation doesn't need to be vocal. But it helps because that's the way we talk. We don't write the way we talk, but we do talk in a very conversational way, which natural language processing and understanding makes easy. So making a conversation with our computers involves them first talking to us, which luckily for us, making computers talk is quite easy. Bell Labs have been doing it since 1961. And you can do it if you have a Mac, or I'm not sure if this works on Linux as well, but you can just type into the terminal, say hello world, and it will say it back to you. And you can do it on the web using the Web Speech API, which is supported in Chrome and Safari and Firefox, I believe, behind a flag. It's quite easy to do. You just give it a simple command and it speaks using the system's language. It's a little bit artificial, but if you want really, really naturalistic sounding language, you could try a service like Ivona, which is the voice of Amazon Echo, or there's services by AT&T or NeoSpeech, and you send them off a request using, you just send them off a request using the API, and they send you back a JSON file which links to the sound response, so you can just play back this really, really beautifully sounding natural voices. And making computers listen is easy. Now, it wasn't always easy. Again, Bell Labs came up with this first. They actually did it years before in 1952. They got a voice recognition system, but it can only recognize numbers and only recognize numbers spoken by one person. So it wasn't very flexible. But deep learning has made this much, much improved recently. Since 2012, Google's voice recognition error rate has dropped from 26% to 8%. To show what a big difference that is, 26% means if you spoke to it in 3 years ago, it would misunderstand every 4th word. If you spoke to it now, it would misunderstand every 12th word, which is a huge, huge difference. And this rate is getting smaller all the time. This error rate is dropping all the time. Baidu, who I mentioned earlier, who are kind of China's Google, if I can be so trite, they say their error rate is down to 6% at the moment, which is one mistake in every 17 words. And to put that in perspective, Baidu say 10% of their search queries, all of their search queries are by voice, which is approximately 500 million voice search queries per day. So they've got a big incentive to make this thing work properly. You can do this again with the Web Speech API, but it's only working in Chrome at the moment. It hasn't been worked on for a little while. It uses Chrome's proprietary systems. I think Firefox are working on an open source version of this, but it's not ready yet. Or you can use a service. And again, Project Oxford offer this as a service. They have speech recognition and intent APIs. You send a sound file to them. It returns you back a text file of what the person said. And Watson, my good friend Watson, also has the same service. The only drawback of doing this through the browser at the moment is that you need some kind of microphone input, very obviously, which means if your browser supports it, you can use get user media. So that would be in Chrome and Firefox, and soon, I think the next release of Edge, it's not Internet Explorer anymore. But it does mean, and if you can't do that, maybe you can do it to fall back in Flash if your browser doesn't support WebRTC, which means that unfortunately, speaking to your browser and having it understand and having it listen to you is not possible in Safari for iOS. I have my own opinions on Safari for iOS. I'm not going to tell you what they are. Making computers understand is much harder. But it is possible, finally. Making computers listen, we've just seen, can be done quite easily, but it doesn't understand what you're saying. It just returns the words that you said. It's just parroting them back to you with no understanding of what you're saying. But now we can have systems that use natural language processing to understand what you're saying. Again, Project Oxford have this thing called LUIS, which is the Language Understanding Intelligence Service. It's invitation only at the moment. And there's a really good startup called API.ai who offer a whole bunch of APIs for you to use this on mobile apps and smart home and Arduino and things. And SoundHound recently released one called Houndify. SoundHound, as you know, have got long, many years of actually listening and understanding. In the background, they've kind of been working on this natural language understanding system, which they said, I don't know whether we should believe them, but they said that all along, SoundHound was just the method to get to Houndify. All the way along, they've been meaning to do this system. And recently, they released this. Again, it's got a couple of nice APIs you can get access to. You just request access to it. To give you an example of how good Houndify is, this is the type of query you can ask it. Show me hotels in San Francisco for tomorrow that are less than $300 but not less than $200. Are pet friendly, have a gym and a pool with 3 or 4 stars, staying for 2 nights and don't include anything that doesn't have air conditioning. And I've checked these queries and they work really, really, really well. The system I like to use, that I've been using quite a lot, playing around with, is this one called Wit. Wit was another startup. They got bought by Facebook earlier this year, so they're now owned by Facebook. So if you use them, your data belongs to Facebook. So whether you want to use them or not, or can use them, is a different call. But what that means is, with all these Facebook inputs, is that the data pool that they have is enormous and their system is really, really, really good. I like them because they've got a lot of SDKs. They've got SDKs for the web, for Node, for Python, for C, for Windows. But I like them because they're really, really easy to use. And I'll just illustrate this quickly with an app that I've been working on just in my spare time, just for fun, not for anything, not for profit or anything. If you've had to buy a ticket from a train station, you'll know it can be quite a frustrating thing. You have to go through 4 or 5 screens worth. You say where you have to give it a place where you're going, start typing in the name, choose the name from a list, say how many people want to go, when you want to go. It can take a couple of minutes. It's not the end of the world, but it's not the most user-friendly thing. And using the website is a bit easier, but not that much. You still have to do, I think I calculated there's about 10 clicks in there, 10 mouse clicks in there, plus typing some data in. With a service like Wit, with this thing that I've been playing around with, you can just say to it something like, 3 adult returns to Chicago, leaving tomorrow and coming back on Sunday. And it identifies from them how many tickets you want, what type of ticket you want, where you're going, when you're leaving, at what time, and when you're coming back. And it's one voice query and it takes about 20 seconds, as opposed to 4 or 5 screens, which can take 2 minutes. There is a drawback. The reason it says Chicago is because it doesn't have British English understanding yet. So any place I ask it to go to, it doesn't understand me, so I have to put on a fake American accent to make queries to it. But that's not insurmountable. Also, it recognizes my name as Pizza. It refuses to understand Peter. So I have to go, it's Peter, that does bug me a little bit more. But Wit is the power behind Facebook's new virtual assistant, which is M. M is very new, it hasn't launched here yet. What's notable about M is that it only works inside Facebook Messenger. But you can ask it questions in natural language as if it were one of your friends or a contact you know. So you can just say to it, oh, I'm going to Chicago next week. I'm looking for a burger, where should I go? And it will reply to you, oh, people say that this place is good. Do you want me to make you a reservation? And you say, yeah, sure. It's all in the app. And it's powered by deep learning systems with a level of humans behind it to correct any mistakes and to train it to get better. And this is kind of a shift that I think we're going to start moving into. We're here tonight to talk about UI, and I want to give you a little prediction about where I think UIs are going to go. Not all of them, but I think there's going to be a big new avenue of UIs opening up here. And it's made possible by NLP, by natural language processing. It's enabled a shift from the GUI to the QE. And QE is the conversational user interface. And we're seeing this with our virtual assistants, and we're going to start seeing it in messenger apps much, much more in the future. This is an example. This is from a service called X.AI, but there are alternatives out there. There's Clara Labs. This is a very similar thing. This is a virtual assistant that only exists in email. You say to her, say you want to make an arrangement with someone, you would say to them, do you want to go for a coffee next week? They say, yeah, sure. And you go, okay, I'll get my assistant to do it. Amy, this one's called, can you find us a time when we're both free next week sometime? And then your assistant, your virtual assistant, will do an email back and forth with the other person, checking that when they're available, where you can go, and then they'll only email you back when an agreement has been made. There's a reason that WhatsApp is worth was valued at $19 billion. That's not just like Silicon Valley craziness. That's because we're going to see these apps, this conversational user interface is going to explode in the next few years, powered by NLP. We can see this because if we look at this breakdown as how people use their phones, we can see that so much time, the biggest chunk of time in every market, is spent in communication. In India, that's up to 47% of time on a smartphone is used for communication. You think, all right, well, that's what a smartphone's for. It's for phone calls and that. But if we actually break that time down more, you can see that it's instant messaging is the biggest, hugest chunk of that, especially in India. 2/3 of that time is spent in instant messaging. In Japan, 40%. In the UK, at the moment, only 25%. In the US, 14%. We still prefer social media. But judging by the trends that we're seeing in other countries, that aren't allowed social media, for example, like in some countries where it's very strictly regulated, we're just seeing there's so much more people use communications apps. And a lot of people are predicting that messaging is the next platform. We've had the operating system where you have discrete apps that do one single thing, but we're starting to see a messaging system where you can do all these things inside the messenger. This is an example of a few new services. There's one called Chat Shopper in Germany. Hasn't launched here yet, but you just buy and talk about clothes with a chatbot. And it makes them, and it sends them to you, you tell it your size, and you can do your shopping through a chat interface. And there's one here called Digit, which I think is US only at the moment, where you do all your banking through a chat interface. Because it's so much easier to talk to somebody than it is to use a GUI in many cases. The model of this is WeChat in China, where you do everything through WeChat. I mean everything. This is booking an appointment with your doctor through WeChat. And people have seen where this is going, and they're making big bets on conversational interface because that's finally been made possible. Conversational UI was not really possible before then. Now it's an idea whose time has come because of these deep learning systems, because of natural language processing. If you want to have a go for these yourselves, there's a startup called Reinfer, which are based here in London. They're still in, they haven't launched yet, but they're doing quite a lot of talks, and you can see them starting to engage with people. This is basically what they offer. They offer text interfaces powered by artificial intelligence. And again, our friend Watson has this service where you can just say the data you need, and it will create a chatbot that keeps talking to the person until it has all that data. So if I tell it that I need to know how many pizzas, where they're going, what the toppings are, what the size is, and then it asks me, what would you like? And I just say, I want a large pizza. They'll go, okay, you want a large pizza, but what toppings would you like on it? And then I would reply, and then it would say, where do you need that to go? It'll just keep asking me questions until I give it all the data it needs. So my prediction is that in addition to all these strands of design, we're going to have to add one more, which is conversation design. It's not going to be everywhere. I'm not going to pretend all of your websites are going to be taken over, but I'm predicting that this is going to be a huge, huge, huge growth market in the next few years. We have these new interaction models, but we still have the same old problems. Privacy is still a big, big problem. I don't know if any of you heard about the Samsung TV scandal earlier this year. Samsung TV is voice controlled, and people suddenly realized that voice control means that your data is being sent to external servers. And because it's using natural language, but it's being trained by humans, people were listening to the things you sent to your TV. Now, most of the time you would say to your TV, okay, change channel. Or, okay, record this. But it was a possibility that you could have the microphone on, and then your wife says, or your partner says to you, oh, remind me of the bank details. And so you just go, oh, it's 0134704. That could happen. This is going to be a bigger problem soon because of Barbie. This is Hello Barbie. Hello Barbie is not out yet. She's coming out hopefully in time for Christmas this year. Hello Barbie is an artificially intelligent powered Barbie. You'll be able to talk to her and she will listen to you and understand and reply back to you. It's like a chatbot but in Barbie form. This will be in thousands of children's bedrooms. Millions of children's bedrooms possibly. The privacy implications on that are going to be absolutely staggering. You can address this in many ways. Google's way to address this is through transparency. If you have used Google search, voice search, you can go on their website and enter your details and it will tell you everything you've said to it with playable sound files. So you can listen back to everything you've ever said to it. You can see that this was the day I was trying to work out how to cook on a beans. Luckily, mine's quite boring. Other ways to address it are to use anonymized services, which is Apple's approach. But we just need to consider this. And the other big implication, of course, is security. This is my friend Kayla. My friend Kayla is the name of the doll. This is not actually my friend Kayla. My friend Kayla is also an AI-powered doll. She's been out since the beginning of this year, possibly the end of last year. You talk to her, she talks back. She's powered by an app which your parents can use, or parents use to control what can or can't be said, set the levels of safety. And it communicates with Kayla through Bluetooth. But some smart person worked out that if you can communicate with Kayla through Bluetooth, then you can hack Kayla through Bluetooth as well. And they were able to very easily make her say things that she really should not have been saying. This is a very mild case. I could have sworn a lot worse than that. But these things are going to be huge. Security is going to be a massive issue when we have these things in our homes and all around us all the time. The ready availability of deep learning, everything that I've showed you today, is just the tip of the iceberg. And it's happened so quickly that we've barely realized. It's come up on us really, really fast. Like 3 years, 3 to 5 years this stuff has happened. And in the case of some of these web APIs that I've shown, they're, without exception, they've almost without exception, they've appeared in the last 18 months. I had to do a job for a client 2 years ago where they wanted us to build a conversational interface, and we had to build the whole thing using like pattern matching and regex and all kinds of stuff, and it was very barely just about functional. If they come back to me and ask me to do that today, I just hook them up to Watson using using JSON. Using Node and swapping JSON files. It's super easy. My conclusion is this. AI is improving rapidly and it will take some jobs. This is unavoidable. But it can't create like us. And it can't improve, and it can improve your work. So all of this is not reason to be scared, but reason to look at it as a huge opportunity and to start thinking about where things are going in the next 2 or 3 years. Thank you very much. Do we have time for questions, or anybody want to ask any questions? Anyone want to ask what I was going to write instead of products on that slide about my friend Kevin? Hi.
Well, I saw an example of a great use of this kind of technology. Google gave an award to a startup in France where an EA application was allowing people, deaf people, to make phone calls because the deaf person were talking to the phone and the application were translating what the other people was saying.
Okay.
Was
yes.
a great use, I mean.
Exactly. Yeah, that's a really good example of like you can use this to help deaf people communicate. Someone can speak to a deaf person. The natural language program just turns it into words and displays it to them. They don't have to hear, they don't have to lip read, they can see what's written. Microsoft have actually, you might have seen this as well, a similar kind of thing. They've released an application that allows you to talk to someone of a different language. I would talk to you in English, it would translate it into Spanish, and I'm guessing, because I'm just presumed, I don't know where you're from.
Italian.
Okay, Italian. It would translate it into Italian, then you would reply to me in Italian, and I would see the result back in English. It's basically the Star Trek Universal Translator is now possible thanks to this stuff. And it wasn't possible 2 years ago. It's kind of phenomenal. Well, it was possible in laboratories and in universities. We couldn't do that. We can now. Hi.
Thanks. Thanks, Peter. I'm curious if
Curiosity is good.
most of the time, always wondering. Assuming that currently feeds computers with all the data about us, you worse people.
Yeah.
And if we assume that human emotions is just part of chemistry and electric, interfaces throughout the body, and if we follow chaos theory saying that everything that we don't understand is essentially a set in order that we can't comprehend just yet, what prevents AIs to mimic or statistically approximate emotions and then go terminate all of the heads?
That was the most science fiction question.
But
I
goes
understand. Yeah, so this is, some people are very worried about the dangers or the risks inherent in artificial intelligence. What if it could become emotional? What if it could do this? And there are people out there, Google, for example, have put together a small brain trust, and they funded it with millions of dollars. Are people looking into that problem? Are people looking into what happens if it becomes too smart, too quickly? A lot of top people, there's a few trains of thought about it. Some people are very worried about this with the singularity. It's when an artificial intelligence becomes conscious and aware. A lot of people aren't worried about it at all. And this is for the reason that we were saying earlier about the creativity, about how we will just program, if we program it to do stuff, even if it learns, it can't learn beyond certain constraints. Andrew Ng, who's a guy I quoted earlier, he's got a very good, quite famous quote, where he said, "I don't worry about the singularity in the same way that I don't worry about overpopulation on Mars." But it is a worry. There's some really good stuff written about it. I'm more of the positive camp, but who can predict?
But that could be interesting to use in the future, the conversation design, or however it's called. If computers can figure out the emotions, at least stress, tone of voice.
Oh yeah, no, I think it can learn emotion fairly, or it can learn to fake emotion. People can learn to fake emotion. There's like sociopaths are born without the ability to have emotion, and they learn how to do it and express it back to you. Yeah, potentially we might see in the next 10 years the first case of someone suing a computer for emotional blackmail or emotional manipulation. It's entirely possible. It's very possible.
But at the same time, it can be used to what you described. So you can detect a certain state of your body that is just half an hour before a stroke, for example.
Exactly.
Or something. So. Yeah.
Oh yeah, I read an article today that a university in Italy, of course, made a huge research that following people with bipolar problems, they could detect by the phone if it was in a kind of depressing mode or overexcited mode.
Okay, so by listening to your speech patterns and understanding what
everything, GPS activities, if you were running,
and so you can understand if you're about to have a bipolar episode or if your mood is elevated or depressed. Yeah, it's going to happen very, very naturally. If you haven't seen Black Mirror, watch Black Mirror. It's an excellent episode about a woman whose boyfriend dies and she signs up to a service which emulates her boyfriend. And it's 2 years ago, or when that was on TV, it's like, wow, this is really far future. Now I look at it and go, that's going to happen in about half an hour.
And they made also an episode about a free call. What was it? A scene that you can use for free. The phone calls from data and everything.
I don't remember that.
I think it was in Black Mirror. But there is a service now giving free calls.
Okay, yeah.
It's called free calls.
It's near future, it's not far future anymore. Sorry, was there a question about that?
Yeah, thanks for the talk.
You're welcome, thank you.
I want to ask, you mentioned about when you're talking about the beginning about the grid, this website builder sort of thing, and you said that it's very smart, but it's not artificial intelligence. So
yeah.
How do you define this line?
That's kind of my artificial distinction, I think. Yeah, what's the difference between smart and intelligent?
Algorithm.
So is it just about complexity of algorithms? But like, how do you say the app is really smart and this app is using artificial intelligence? It's kind of the same.
Yeah, I mean, it is, you're right. I was using it as a rhetorical device to kind of say, it's not really, I mean, it's understanding it's not understanding the content of the images necessary, it's not understanding the content of the text you put into it, it's doing it on quite a surface level. So it can do face detection, but it doesn't know that it's necessarily a picture of, beyond that it has a face, it doesn't necessarily know the difference between a photo, if you had a photograph of a painting or a photograph of a person, it wouldn't know, it would just detect a face in there. So it's kind of a faint distinction. I'm sorry if that confused you.
No, it was my question more of like when it stops being very smart and starts artificial intelligence, where this line
where it stops being smart, starts being intelligent. I think for me it's understanding what's contained in the thing, not just seeing the surface of it, but understanding what's inside it. Knowing the difference between a picture, knowing the difference between a person and a painting of a person. That for me I think is more intelligent than smart. But that's totally artificial distinction. Thanks.
Peter,
Yes.
what's the speed of these services like? You know, obviously speech-to-text recognition might be quite fast, but recognizing images in real time and getting back to the metadata of it. How fast is that?
So you can, I think in most services it's really quick. It's almost instantaneous. But it's giving you a fairly low level of certainty. If it's not giving you back, it could go on more and give you back a slower response, but with more certainty. But it's prioritizing speed over fidelity, I think, in most cases. But it is very, very quick. Like if you send a request off, you'll get a response back in a few seconds.
So an example of your app you're working on in your spare time.
Yeah.
Is it real time?
It's as real. You'll see it spinner for a few seconds and then it's back to you. If you mask it slightly with a little bit of clever UI to let you know that it's thinking about something, it's not nice.
CSS animations.
Yeah, CSS animations, exactly. And then you can update it with React. There you go.
Brilliant.
I think that's probably all we've got time for. Oh, sorry, one more question.
Why do you think there are so many large companies not using AI, like ASOS, for example?
Why do I think there's so many companies not using it? I think, first of all, like maybe there's not been a lead up to now. But I think we will start to see, I can give you the example of, not ASOS, but do you know Zappos? Zappos? It's an American retailer, kind of a similar thing to ASOS. And they are using services like this now. They're using a service where you can just send it a photograph of something, and it will do automated lookups first, and then it will come back and give you back the information about what you're looking for and maybe help you find it. It's partly human and it's partly artificial. But a lot of this stuff is genuinely so new and has only just become available. And I think that people just kind of haven't really evaluated. People have been wanting to do this stuff for years, but maybe have not realized that actually now you can. But there is a cost also element to it. Although Watson is free for developers and it has very generous limits, if you're on a site like ASOS with millions of people, and if even just 1 million people were using that service a day, there would be a cost. So there is an issue in that. But I think partly it's just a case of a lack of awareness because it's happened so quickly. I thought there were a few services when I started this talk, and then everything I typed in came back like 5 new services I've never heard of. Thanks. And with that, I'll say thank you very much again. Thank you.